Today, I'm making a slightly different video than you're used to seeing from me. Today, we'll be looking at one of the most popular and interesting objects in the universe, black holes. However, I'm going to try not to tell you things about black holes that most people already know. The standard facts, like the fact that light can't escape them, or that they're incredibly large. I want to tell you about incredible things and effects these objects have that many people don't know yet. Before I begin, though, I'll briefly summarize the most important points for those who might be new to this and don't know much about black holes yet. Black holes are regions in space where gravity is so extreme that nothing can escape, not even light. They usually form when massive stars collapse at the end of their lives. At the edge is the event horizon, the boundary beyond which there is no return. What makes black holes so fascinating is that they distort space and time itself. At their center lies the singularity, a point of infinite density where our physics breaks down. They come in various sizes, from stellar black holes to supermassive giants at the centers of galaxies. And here we begin with the first interesting fact that many people don't know. If you ever fell into a black hole, you won't be spaghettified immediately, at least not with supermassive black holes. That only happens with smaller stellar black holes. So you could actually fall into a black hole, make it past the event horizon, and survive. With supermassive black holes, the tidal force at the event horizon is surprisingly weak. The horizon is so far from the center that the difference in gravitational force between your head and your feet remains minimal. You would barely notice the transition. No dramatic tearing, no pain. Only much later, as you approach the center, would the tidal forces increase. With stellar black holes, however, everything is much more compact. There you would be stretched into a noodle, even before reaching the event horizon. So size makes the crucial difference for your survival, at least temporarily. This brings us directly to the next bizarre effect that occurs when you approach a black hole. Imagine you're hovering near the event horizon of a black hole. Space-time is so extremely curved here that something completely surreal happens. You could actually see your own back. Light, which normally travels in a straight line, is forced onto curved paths by the immense gravity. The photons emanating from the back of your head or your back don't take a direct path through space. Instead, they are deflected around you by the extreme curvature of space in an arc that eventually leads them back to you. This means that light rays from your back could literally bend around your body and enter your eyes from the front. You would see yourself from perspectives that are normally completely impossible. The back of your head, your shoulders from behind, perhaps even your entire face from an impossible angle. It would be like being in a cosmic hall of mirrors, only without the need for mirrors. Gravity itself bends the light so much that you become your own observer. My next point probably isn't a groundbreaking fact for everyone. I still wanted to include it because it's just so bizarre. It's about time and crossing the event horizon. Imagine you're watching someone fall into a black hole. From your safe distance, you'd see something strange. The person slows down, their movements become increasingly sluggish, as if someone were playing a movie in slow motion. The closer they get to the event horizon, the more extreme this effect becomes, and then they freeze completely. From your perspective, the person never actually reaches the event horizon. They remain there, so to speak, forever, becoming redder and darker until they finally become invisible. But what about the falling person? They experience something completely different. From their point of view, they pass the event horizon normally without stopping. Time continues to flow for them, while for you outside, time essentially stands still. Two completely different realities, both true at the same time. Time behaves completely erratically around black holes, almost like a time machine. The closer you get to a black hole, the slower time passes for you compared to the rest of the universe. For example, if you were to spend just 1 hour near the event horizon of a supermassive black hole, years, decades, or even centuries could have passed on Earth, depending on how close you were. This isn't science fiction, it's measurable physics. Astronauts on the ISS actually age slightly slower than people on Earth, but this effect is amplified dramatically around a black hole. Gravity not only warps space but also time itself. Einstein predicted this in his theory of relativity, and black holes are essentially the most extreme laboratory for it. You could theoretically travel into the future simply by being near a black hole and then returning. Imagine you orbit a black hole for what feels like just a few hours. You climb back into your spaceship, fly back to Earth, and suddenly 1,000 years have passed. All of humanity has evolved. Civilizations have risen and fallen, while you haven't aged a single day. Many are probably already familiar with this effect from the film Interstellar, where the astronauts experience the same phenomenon. But beware, it only works in one direction. You jump into the future, but there's no way back. Your friends, your family, everyone you knew, they would all be old or dead by now. While for you, hardly any time has passed. Another fascinating fact is that black holes actually emit a sound, even though there is supposed to be absolute silence in space. These are not sounds in the classical sense, which we could hear with our ears, but rather pressure waves that an active black hole sends into the surrounding hot gas of a galaxy cluster. These waves are created when matter falls into the black hole, and some of it is ejected in enormous jets. This rhythmically compresses and expands the gas, much like sound waves in air. The supermassive black hole in the Perseus galaxy cluster is particularly famous. There, astronomers were able to measure actual pressure waves, whose frequency, while millions of times lower than human hearing allows, mathematically corresponds unambiguously to a musical tone. This tone is the lowest pitch sound ever measured in the universe. To make it audible, researchers greatly upscaled the frequencies. The result sounds like an eerie plaintive groan or roar, almost alive. In the next few seconds, I'm going to play you a short sound. What you're hearing is a real recording of a black hole deep in the universe, which is pretty crazy when you think about it. Next, I wanted to talk to you about the lifespan of black holes. Because yes, they too will eventually die. Black holes seem indestructible, eternal, absolute. But even these cosmic monsters have an expiration date. The physicist Stephen Hawking discovered that black holes actually emit radiation, the so-called Hawking radiation. This causes them to slowly but surely lose mass. How does this work? Right at the event horizon, particle-antiparticle pairs are constantly being created out of thin air, a quantum mechanical effect. Normally, these pairs annihilate each other immediately, but at the event horizon, it can happen that one particle falls into the black hole while the other escapes. The escaped particle is Hawking radiation, and the black hole loses energy as a result. The crazy thing is, the smaller a black hole gets, the faster it evaporates. A stellar black hole would take an unfathomable 10 to the power of 67 years to completely disappear. Supermassive black holes take much, much longer, 10 to the power of 100 years or more. To put that into perspective, our universe is only 13.8 billion years old. That's 10 to the square of 10 years. The time it takes for a black hole to evaporate is so absurdly long that numbers completely lose their meaning. In our entire observable universe, there are about 10 to the squared of 80 atoms. The lifespan of a black hole is longer than that. It almost doesn't make sense to think about it because it's just so absurd. And supermassive black holes with 10 to the power of 100 years, that's a 1 followed by a 100 zer. Even if you were to count every second since the Big Bang, every second in the life of every star, every planet, you wouldn't even have captured a tiny fraction of that time. It's literally unimaginable. The entire history of humankind, all civilizations, all the stars that have ever shone, all of this is less than the blink of an eye in this span of time. The crazy thing is, black holes will be the very last objects in the universe. Sometime in the unimaginably distant future, all the stars will have gone out. No new stars will be born because all the gas will be used up. Planets will disintegrate. Galaxies will dissolve. The universe will become cold, dark, and empty, and then there will only be black holes. They will reign as the last remnants in a dead universe, lone guardians of absolute emptiness. Trillions upon trillions of years will pass as they slowly evaporate. One by one, they will disappear. In the end, after the last supermassive black hole has evaporated, there will be one last colossal flash, a final explosion of energy and radiation, and then nothing. Absolute darkness. No matter, no structure, only dilute radiation in an endlessly expanding, cold universe. This is the true end. Not with a bang, but with the whisper of a dying black hole. I hope you learned something new from this video, and that you enjoyed it. Perhaps I'll make more videos like this in the future. Let me know in the comments. I hope to see you next time.